Question number 4 of this exercise says that a cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter of the hemisphere that it can have? Also, we have to find the surface area of the solid formed. So, as per the given information in the question, let's first try and draw how the solid will look like. So, as we can see that here is the figure that we get from the question's information, wherein we have a cubical block with side 7 centimeters surmounted by a hemisphere, and this is how the top view of the solid will look like. The first part of the question had asked us that what is the greatest diameter of the hemisphere that it can have. Now from the figure, it's very clear that the greatest diameter that the hemisphere can have is this part, which is nothing but the cube's edge. Otherwise, a part of hemisphere's rim, which is the circumference of its circular base, will lie outside the top part of the cube. So the greatest or the maximum diameter that it can have is the cube's edge. So what we can write from this information is that the diameter of hemisphere equals 7 centimeters. So from this we can calculate the radius of the hemisphere, which will be half the diameter. So we get the radius of the hemisphere as 7 by 2 centimeters. Now that we have solved the first part of the question, let's go on to the second part, which asks us to find the surface area of the solid, that is, the total surface area of the solid. Now, it's very clear from the figure that we'll have to include the total surface area of the cube. So if we take the side as L, we can write the formula to find the total surface area of the cubical block to be 6L squared. But a part on the top surface of the cubical block is being covered by the hemisphere's base. So we'll have to subtract the area of the base of the hemisphere. So the area of the base of the hemisphere is pi r square, as the base is a circular base, r being its radius. Now, the curved surface area of the hemisphere will also be taken into consideration. So we'll have to add the curved surface area of the hemisphere, which will be 2 pi r square. Now on simplification, we can write it as 6L square plus pi r square. Now let's substitute the values. We write it as 6 times 7 times 7 plus pi, which can be substituted by 22 by 7, times r, which is 7 by 2 as calculated in the first part. Now we'll simplify it. 7 sevens are 49, and 49 times 6 gives us 294. For the next part, we can cancel out 7 and 7, 2 and 22 with 11, and 7 by 2 will be 3.5. So 3.5 when multiplied with 11 will give us 38.5. And this one added to 294 will give us the answer as 332.5 centimeter square. And this is the total surface area of the solid, which is formed by a cubical block of side 7 centimeter, which is surmounted by a hemisphere having a greatest diameter of 7 centimeter.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.